Today we're going to be learning scientific notation. Scientific notation is an easier way to write really big or really small numbers. This is how we're going to be writing it. C stands for coefficient. 10 is the base, and it's always going to be 10 for scientific notation. The n is the exponent, which is always an integer, so it's always going to be a positive or negative whole number, and it's going to represent the number of times the decimal moves. So for scientific notation, we always want to remember if a number is bigger than 1, then it's going to have a positive exponent. For example, 350,000. That number is bigger than 1, so it's going to have a positive exponent. If a number is smaller than 1, it's going to have a negative exponent. So for example, 0.00825 is less than 1, so it's going to have a negative exponent. So if it starts with zeros in the front, you know that your exponent will be negative. So let's practice a few problems. Number 1 is 350,000. So if it doesn't have a decimal, the decimal is going to go at the back. And we only want one number to the left of the decimal. So right now we have 1, 2, 3, 4, 5, 6. We only want 1. So I'm going to move my decimal between the 3 and the 5. That way, I only have one number to the left that is not 0. So my new number is 3.5, and you can cross off trailing zeros, so zeros at the end. Then I'm going to have times 10. It's always times 10 with scientific notation. And then my exponent. So I'm going to count how many times I moved that decimal. So I moved it 1, 2, 3, 4, 5 times. So my exponent is going to be a 5. And since 350,000 is bigger than 1, I know that my exponent is going to be positive. So I have a positive 5 as my exponent. Example number 2, 4,092,000. It doesn't have a decimal. So I put one at the back, and I want to move it so I only have one number to the left. So I'm going to move it between the 4 and the 0. That way I only have one number to the left that is not 0. So my new number is 4.092. Remember, I can cross off the zeros at the end, times 10. Now the exponent is how many times I moved it. So 1, 2, 3, 4, 5, 6. So my exponent is a positive 6 because this number is bigger than 1. Number 3, 8,000 doesn't have a decimal. So I'm going to put it at the end. And I want to move it to where I only have one number to the left. So I'm going to move it between the 8 and the 0. So my new number is going to be just 8. You do not have to add the 0.0. So 8 times 10, and I moved it 1, 2, 3 times. So my exponent is a 3, and it is a positive 3 because 8,000 is bigger than 1. Number 4. Okay, so it doesn't have a decimal, so I'm going to add one at the end. I want to move it to where I only have one number to the left. So I'm going to move it between the 6 and the 1. So I only have one number to the left. So I have 6.102. So I can cross off the zeros that are at the end. I can't cross off the 0 in the middle because it is between two numbers. You can only cross off zeros at the end. Then I have times 10. And I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. I know that it is a positive 9 because this number is bigger than 1. Okay, number 5. There is already a decimal in the number. So all I need to do is move it to where I only have one number to the left that is not 0. So I'm going to take my pen and follow it and stop when I get to the first number that is not 0, and I'm going to put my decimal after it. So now I have one number to the left. that is not 0. So my new decimal is 8.25 times 10, and I moved it 1, 2, 3 times. So my exponent is a 3, but this number is less than 1. So my exponent is going to be a -3. So less than 1. If it starts with zeros, you're going to have a negative exponent. So number 6, it already has a decimal, so I don't need to add it. So I'm going to start with my pencil or pen and stop when I get to the first number and put my decimal after it. So I've got 4.2 times 10, and then count the number of places I moved my decimal. 1, 2, 3. I know it's a -3 because this number is less than 1. Number 7, I have my decimal, so I want to take my pen and go along until I hit the first number that is not 0 and put my decimal point after it. So my new number is 9 times 10, and I moved it 1, 2, 3, 4, 5 times, and it is a -5 because this number is less than 1. Okay, so now we're going to, so this one was converting standard, which are just regular numbers, to scientific. Now we're going to work backwards and go from scientific to standard. So number 1, my coefficient is 3.25. So 3.25, I'm going to move my decimal 2 times. But since it's negative, I know that that number is going to be really small. So you can also think of it like a number line. The negatives are on the left side. So I know I'm going to move my decimal 2 places to the left. So I have 1, 2. What fills in here are zeros. So my number is 0.0325. That is my standard number. That's the regular number. Okay, number 2, I've got 1.9. I'm moving the decimal 5 times. It is negative, so I know that I am moving it to the left to make that number smaller. So I have 1, 2, 3, 4, 5, new decimal. And I fill in with zeros. So my number is 0.000019. Number 3, so I've got a 3. Remember, if you don't see a decimal, it always goes at the back. And I have a +4. So I know I'm going to be moving it 4 times. And if I think of a number line, the positive is to the right. And 4 is positive, so that means I want the number to be bigger. So 1, 2, 3, 4. So my new number is 30,000. Last example, number 4, 5.8 times 10 to the 6th. I know I am moving the decimal 6 times. It already has a decimal. 6 is positive, so I want that number to be bigger. So I'm going to move it to the right. Just like on a number line, the positive numbers are to the right. So I've got 1, 2, 3, 4, 5, 6, and I fill in zeros. So my number is 5,800,000.